The boil. The typical boil time is around 90 minutes. The boil accomplishes several things: precipitation of proteins and other solids that might cause hazing in the beer, removal of undesirable chemicals, sanitization of the wort, adding yeast nutrients, and imparting bitterness through the addition of hops. These are hops. Hops are generally used in pelletized form as shown, mainly for convenience in terms of storage and overall volume. They are measured according to a recipe into containers, as was shown. In the natural form, hops grow into a soft cone of petals that resemble the shape of a small pine cone, only very soft. As explained earlier, hops provide the bitterness to the beer, and depending upon the style, add varying degrees of flavor and aroma as well. Hops are added at different times during the boil. Early additions are for bittering, mid-boil additions for flavor, and end of boil for aroma. There are many different varieties that are suited for each of these attributes, as well as varying flavors and aromas. Hops are added to the fermented beer in a process called dry hopping. This adds even more hop flavor and aroma to styles such as pale ale and IPA. Other ingredients may be added during the boil, such as dried malt extract as shown here, to increase the overall gravity of the wort. Strong ales such as the Shockwave Scottish Ale require more potential sugar than we can extract during the mash. Therefore, extract is added directly to the kettle.
I guess I'd leave a little bit out.
Next, the wort is moved from the kettle to the fermenter in a process called knockout. At the end of the boil, a whirlpool is generated in the kettle to settle all the hops and solids out of the wort, and then it is cooled to near room temperature by pumping through a heat exchanger. Oxygen is introduced into the flow to allow for yeast respiration, which helps the yeast cells to replicate. The wort is pumped into the bottom of the fermenter as shown. Yeast is introduced to the wort in a process called pitching. In this case, the yeast was harvested into a keg from a previous fermentation and then pumped into the fermenter prior to knockout as shown. Alternately, yeast can be added into the flow of wort during the cooling process or after the wort is completely pumped into the fermenter. After runoff is complete, the grain bed is removed from the mash tun. At the pump house, this is a manual process. The spent grain is shoveled into large trash containers, which are then moved into the alley where a farmer picks them up to feed his cows. About 80% of the nutrients are removed during the mash, leaving 20% to be used as feed and filler. Grain out can be a hot, sweaty job because the mass of grain is still very hot. As can be seen, the mash tun has a false bottom, which is essentially a screen that allows the liquid to drain out from the grain bed and transferred over to the boil kettle. Here, the mash tun is nearly cleaned. All that remains is to scrub and then spray it out. The boil kettle is also scrubbed, as well as other outside pipes and hoses. A cleaning cycle is also run on internal pipes, the heat exchanger, and brew hoses to remove any residues, and then all is sanitized with very aggressive chemicals. The yeast metabolizes the sugars in the process called fermentation. The bubbling seen in the bucket is carbon dioxide from the fermentation. A complicated series of chemical reactions take place during fermentation, resulting in creation of ethanol and carbon dioxide, as well as other desired flavor compounds. The metabolic activity is so vigorous that the fermenters must be cooled using chilled glycol that is pumped around the jacket of the tank. The glycol is metered through these white pipes by electronic control to ensure that the fermentation temperature is maintained to precise levels. Once the beer is finished fermenting and has conditioned, it is transferred from the fermenter to the serving tanks. It normally takes about 10 days before an ale is ready to be transferred. These serving tanks could be thought of as just like big kegs. They are 300 gallons each. If the beers need to be clarified, they are filtered as they are transferred into the serving tanks through this filter unit. Thick paper filters in between these black plates capture the yeast and other solids as the beer makes its way through the filter. The beer is carbonated by forcing CO2 gas into the beer. The carbonation is tested using a special meter. Then the beer is served directly from these tanks to each of the 3 bars through these beer lines, which are connected to the bottom of the serving tank. The lines then route to the top of the cooler to the draft distribution system, which is in the upstairs walk-in cooler. The distribution system splits the beer flow from the single serving tank line to 3 separate lines for each bar. The beer travels up to 150 feet from tank to tap. Because of this distance, the lines must be cooled with chilled glycol to keep the beer cold on its way through the building. The distribution system might look confusing at first glance because there are so many lines, but it is really quite simple if a single line is traced from start to finish. The hot and cold water used in the brewing process is stored in these large tanks. The water used for the mash process is heated to 190 degrees using an electrical immersion heater. 35-degree water is then used to cool the wort after the boil, which heats it back to 150 degrees. This water is dumped back into the hot tank to be used for the next batch. Lab samples are taken of the beer and analyzed at various points in the fermentation process. Initially, cells from the yeast slurry of a previous batch are counted and checked for viability before pitching into a new batch. This is done to ensure that the proper amount of yeast cells are used and that they are healthy. Typically, a starting point for pitching is 10 to 15 million cells per milliliter, which is about a half a teaspoon. Now that is a lot of cells. Then the cells are counted the next day after pitching to see how much they have replicated. Ideally, they should triple. To count the cells, the liquid is diluted and placed on a special slide. Under a microscope, a grid on the slide is used to count the individual cells, and then by simple math, the total amount per milliliter can be determined. In addition to cell count, the pH and specific gravity are measured to provide an indication of how complete the fermentation process is. Records of each lab analysis are kept on a computer spreadsheet. This completes the beer education video. Hopefully it has been interesting and that you have learned the basics of how beer is brewed at the Pumphouse. This basic process is the same whether done in a